today's lesson is a continuance of solving triangles in 3 dimensions. In example 23, we have a lamp pole standing on, let's say, grass. Now remember, when you have a pole or a building or a man standing on something, the angle that that object forms with the ground is always 90 degrees. So here at angle A, we have 90 degrees. They also tell us that angle D and angle B is theta, and angle C is beta, and BC is x units long. In question A, you have to calculate the size of angle BAC. So it's this one in the corner of A. How can we do that? How do we calculate that angle size? Interior angles of a triangle. So it will be 180 degrees minus theta minus beta. You can also write it as 180 degrees minus theta plus beta. Because if we add those two and subtract it from 180, we'll get the green angle A. And remember, you have to write your reason, interior angles of triangle. Now with question B, they say, show that AB, in other words this side length, equals x sine B over sine theta plus beta. This side length is part of two triangles. It can either be the top triangle or the grass triangle. Now the grass triangle has more detail in it, so I'm going to use the grass triangle, and always redraw the one that you choose as a single triangle, not part of a 3D sketch. So this is A, B, C. B is theta, C is beta, A is 180 degrees minus theta plus beta, and BC equals x. I want AB. Now you have to look for, is there a 90-degree angle somewhere in that triangle? Is there? No. So we can't use the normal sine, cos, and tan functions. You have to rely on the sine or the cos rule. Which one can we use here? Sine rule. Because this question mark has a chummy here as an angle. And angle A has a side length opposite it, so those are two chummies. And there's my propeller. I use the sine rule. AB over sine beta equals BC, which is x, over sine 180 minus theta plus beta. I want AB alone, so I'm going to multiply with sine beta to cancel it out, and might multiply with sine beta there. Now I have AB equals x sine beta over, you quickly draw your cos diagram, 180 minus is in the second quadrant, and sine is positive there, so the denominator is sine of theta plus beta. And that's what they ask you to prove. For question C, let's just they say that AB equals AC. So our normal picture, AB equals AC. What does that mean about angle B and angle C? They are the same. If AB equals AC, you can say that theta equals beta. Now they ask you, show that AB is something different than the previous one. Here we have to show that AB equals x times sine beta. Now they say AB equals x over 2 cos theta. So let's use this answer, the previous answer. AB equals x times sine beta over sine theta plus beta. But I'm going to use this clue. Theta equals beta. So you can either change all the betas to theta or all the thetas to beta. But they want a theta. So I'm going to change all the betas to theta. AB is therefore x times sine theta over sine theta plus theta. And now you get x times sine theta over sine 2 theta. This is a double angle. X times sine theta over 2 sine theta cos theta. The sine thetas can cancel out. And I have x over 2 cos theta. And that's what you had to prove. With question C2, they ask you to show that AD is the length of the lamp pole, equals x over 2 sine theta. Because the lamp pole is part of this triangle, I'm going to redraw this triangle with all the detail inside. There it is. I have a 90 degrees because the lamp pole forms a 90-degree angle with the ground. If you have a 90-degree angle, you can use the normal sine, cos, and tan functions. You don't have to use the sine or the cos rules, but you can. I have to work out AD. I normally use angles that are not double or compounds. I'm going to use the theta angle. And AD is adjacent to the theta angle, and the other side length that I have is opposite. So this is opposite and this is adjacent. Which trigonometry function? Tan. Tan uses opposite and adjacent. So tan theta equals opposite x over 2 cos theta over AD. But we want to work out AD. So I need to get AD alone. I'm going to multiply here with AD to cancel it out. But then you have to multiply on the left hand side with AD as well. AD is still not alone. There's a tan theta multiplied to it. So I can divide with tan theta. And then I have to divide here with tan theta as well. Now I'm just going to rewrite everything. Tan theta, AD, these two cancel out, equals x over 2 cos theta divide by tan theta. It's x over 2 cos theta. There's an identity for tan, that is sine over cos. But I can't divide with fractions, so I turn the divide into a multiply. Then the sine over cos becomes cos over sine. The two cos's cancel out, and I have AD equals x over 2 sine theta. And that's what you had to prove. Okay. Any questions?